Properties of water. To understand the nature of water, we have to reach back a little bit to our chemistry knowledge and review what electronegativity is and how electronegativity of oxygen and hydrogen relate to each other. What is electronegativity? It measures the ability of an atom in a chemical compound to attract electrons from another atom in the same compound. Let's draw an oxygen atom and two hydrogen atoms combined to each other through covalent bond. Here's the oxygen atom with its valence electrons, and it shares one electron pair unevenly with each hydrogen atom. The area around the oxygen is a little bit negative and around the hydrogen is a little bit positive due to the uneven sharing of the electrons among the atoms in the molecule. Because positive and negative poles are attracted towards each other, the molecules form hydrogen bonds with each other. The dotted purple lines are the hydrogen bonds. They are intermolecular forces, the forces that exist between the individual water molecules. The reason for the uneven electron sharing is that the oxygen atom has a higher electronegativity compared to the hydrogen atom. Now let's look at the period. The oxygen's electronegativity is 3.5 and the hydrogen's is 2.1. We subtract the two numbers from each other. The difference is going to be 1.4. The difference between the electronegativity of the atoms is a great indicator what type of a bond they form. If the difference is between 0 and 0.4, the atoms form a nonpolar covalent bond with each other. If the difference is higher, up to 1.7, the atoms form a polar covalent bond with each other. And if the difference is between 1.7 and 3.3, the atoms do not form molecules, but rather an ionic compound through ionic bonds. Now let's examine the properties of water. There is the water molecule and its negative and positive poles. So what are the properties of the water that are the results from its polar nature? Here are some water molecules, and they form hydrogen bonds with each other. The hydrogen bonds are responsible for forming big water droplets. When same molecules stick together, it is called cohesion. Hydrogen bonds are also responsible for high surface tension. The water molecules are attached to each other, so small, tiny bugs, such as water strider, is able to walk on the surface of the water without breaking through. The other water property that water can not only stick to its own kind, but to other polar molecules come handy for sure for the plants. Water needs to reach every part of the plant coming from the soil. Inside of the plant, there are tiny tubes called xylem that carry the water. Hydrogen bond that forms between different kinds of polar molecules is called adhesion, in that case between water and the xylem. We can also observe adhesion when we pour water into a thin glass graduated cylinder. At the wall of the glass, we observe that the water climbs up a little bit compared to the bottom of the meniscus. It is also because water and the glass also forms hydrogen bond with each other. Let's have a cup of water. Place the tip of a paper towel into the water, and the water will climb up in the paper towel, defying gravity due to adhesion and cohesion. Liquid climbs in defiance of the force of gravity called capillary action. While opposite poles attract to each other, similar poles repel each other. Almost everything contracts when it cools down and increases its density. It is also true for water until 4 Celsius. But ice, the solid state of water, is less dense than the liquid water. Below that temperature, the water molecules start to arrange themselves into a crystal structure that takes up more space than the same number of molecules in liquid state. So, at or below freezing temperature, lakes freeze from the top. The ice is a great insulator, preserving the life in the water during freezing time. Water molecules form hydrogen bonds with each other. The water can absorb a lot of thermal energy without having much change in its temperature. It has a high resistance to temperature change. It has high specific heat. Specific heat means how much energy 1 kilogram of material needs to increase its temperature by 1 Celsius. Phase change. It is only the water that we can find all of its 3 states of matter naturally on earthly environment: liquid, gas, and solid. Solid to liquid is called melting, and liquid to solid is freezing. Liquid to gas is evaporation, and gas to liquid is condensation. Gas to solid is deposition, and solid to gas is sublimation. Let's think about when it is really hot and we would like to cool down. What is a good option for that? Make our skin wet. When water evaporates from our skin, it takes thermal energy away from our body. Because water has a high heat of vaporization, it has high evaporative cooling effect on the organisms. And the last one is water is the best solvent. It dissolves salt, sugar, for example. It dissolves more different substances than any other solvent known because many compounds are either molecules or made up of ions, so their polar nature make them attracted to the water molecules, keeping them in the solution. Even nonpolar molecule, such as oxygen gas, dissolved in water in some extent. And now summarizing the properties of water due to its polar nature. It shows cohesion, surface tension, adhesion, capillary action. It happens that freezing starts at the top of the lake, high specific heat, high evaporative cooling, and great solvent. Thank you so much.